One thing that you'll inevitably run into with your photogrammetric models is noisy reconstructions. What do I mean by this? Well, if we look at the model we've been using for the last two lectures and spin it around, you can see some points floating out here in space. They're disconnected from the rest of the point cloud. These are caused by bad matches, which might in turn be caused by less than perfect quality images, or particles in the water column, or noise in the camera distortion model. There's lots of sources for these errors. But the goal of this lecture is to show you a few ways to try to clean up these spurious points. The first method is at the very beginning of the processing chain to try to identify and remove bad images. We've discussed in other lectures ways to visually filter them, just by eye, looking for things like fins or divers in the image frame or bubbles, things like that. But Metashape has a nice tool that can help also in this regard. Start by switching to the Photos pane. Use the View menu Photos if this pane is not visible in your workspace already. Then right-click on any image and select Estimate Image Quality. This will take some time to run on long data sets. But when it finishes, switch the view in the Photos pane to the Details view. You might have to make the photo pane a little bit bigger to see all the columns. Click on the Quality column to sort by this quality metric. Lower numbers mean lower quality, and higher numbers are better. 0 is bad and 1 is good. Now, there's no hard and fast rule what is the cutoff for a good image or a bad image, but the general idea is that removing low quality images can improve the results of your model. To remove a single or a bunch of images, select the ones you'd like to remove, right-click, and choose Disable Cameras. Note that you'd want to do this before doing all of the image matching. So this is really the very first step in your processing. You could double-click on the images to look at them and see if they're really bad or not. In this case, if we click on the worst one, we can see that it's an oblique view, and this probably ranked low because the low contrast for the distant part of this scene. But overall, this isn't a horrible image. We can see how it would be ranked lower than the highest quality images in this data set, however. Let's take a look at one of those. You can see in this example, it's just overall a sharper, more contrasty image. But anyway, this lowest ranked image is not a great example of a bad image, so I'm going to show you a better example of a bad image that's found in this way. I have another data set showing where this could really help. This data set was one that I did indoors as part of a training exercise. It's just some chairs in a room. Notice that the worst image in this data set has a quality of 0.43 compared to the worst image in our coral data set, which was 0.60. If we click on this worst image here, you can see that it's quite blurry. It's not a good image at all. And if we compare that with the best image in this chair data set, which is quite sharp, you can really see the difference. So the point here is eliminating blurry images with this tool is one way that can help clean up noisy models. The second thing that you can do during processing is careful choice of your bounding box. Remember, when you compute the dense cloud from the sparse cloud, anything outside the bounding box is discarded. So if we look at the sparse cloud of our test data set, we can see that there is all sorts of noisy bits along the edges of our model that we've cut out by careful placement of the bounding box. If we rotate to look edge on this data set, you can see that there are some points both above and below the main point cloud that have likewise been eliminated by placing them outside the bounding box. So this too is a powerful tool for getting rid of at least the most extreme outliers. Another choice you can make during processing is the level of depth filtering that you decide to apply when computing the dense cloud. Check the dense cloud dialog box under the advanced tab here, and you'll see that there are options ranging from disabled to mild moderate, and aggressive. This can make a big difference in filtering noisy points. Here I'm showing first a version of this dataset with depth filtering disabled. You can see all sorts of stray points above and below the main plane. As an aside though, note that these are cut off at the bounding box, however, as expected. In contrast, if we look at the same dataset with aggressive filtering, you can see it's much cleaner. It's not perfect, but it's certainly much cleaner. So note that all of the other settings for these two examples, including bounding box placement and every other setting for the matching, are exactly the same. The only thing that's different between these is the level of depth filtering. So once your depth cloud has been computed, there is a way to do some automated cleaning of points based on a confidence metric that Metashape computes. Basically, this is a measurement of the uncertainty of the point locations. Points with higher uncertainty, or lower confidence, are more likely to be noise, so we can try to flag those and get rid of them. Note that for this to work, you have to click Calculate Point Confidence when you make the dense cloud. The first thing to do is look at the confidence values. Up here under the dense cloud button, switch from the dense cloud to the dense cloud confidence. In this view, red is lower values and blue is higher values, higher confidence. So the red ones are the ones that you'd like to get rid of. You can see that the points that stick up off the plane are lower values, even though some of these are real and some are noise. So that's the trick, selecting a threshold here that keeps good points but deletes bad ones. To do this, go under Tools, then under the Tools menu, Dense Cloud, and Filter by Confidence. Increase the minimum value here to filter points. You have to play around with this value and inspect each dataset. There's not a single threshold that works always, but I can say generally small values can make a big difference here. So, for example, a value of 1 in this case hardly changes anything, but a value of 2 eliminates a lot of points. I can't tell you what's right or wrong. You need to evaluate that for yourself in each individual case. But switching back and forth here between the views and trying different numbers is the way to go to make an informed decision in your particular case. The final tool that you can use is manual elimination of bad points. This is pretty simple but very labor intensive. Just use the selection tool here to highlight points and then click the delete key to remove them. It's simple. It's really effective if there are just some strange bad area that you want to get rid of. But it is a very tedious way to make lots of edits across the entire model. So it's good to have this in your toolbox if you need it, however. So that's a quick summary of some of the tools that you can use to improve the quality of your Metashape models. You'll have to play around with them to decide what works best for you and your sites and your data and your analysis needs. But using them in combination will really help you generate the best possible model given the data you have. Happy editing!